Hi, in this video I'm going to discuss tutorial 1 question number 10. We have f of x. We need to prove that f of x has two distinct real roots for all value of k. How we can do this? Remind, if f of x has two distinct roots, we know that f of x, the discriminant of f of x, b square minus 4ac should be greater than or equal to 0. But in this question, as you need to prove that f of x has two distinct real roots, right, for any value of k, we have to prove mathematically that discriminant of this function f of x greater than to 0. How we can prove this? You can't take at the beginning b square minus 4ac greater than to 0. Remember that. We need to prove it. How we can do that? First, we need to write b square minus 4ac. Simplify that. You need to prove mathematically your expression for b square minus 4ac positive for any value of k. Let's see how we can do that. To write the discriminant, we need to write down ABC. A is 2, B k plus 3, C k. Now I'm going to write b square minus 4ac. B square minus 4 times a times c. We can simplify this expression. Take square to this bracket. Here we have minus 8k. We can simplify this expression. Right. Now, what we have to do, mathematically we need to prove that this expression is positive. Remind this, we call these expressions are always positive. Right? We call always positive expressions. If you look at this, x square, this is always positive. When you put any values into x, you're going to get a positive number, right? When x equal to 0, you're going to get 0 for x square. So we can say that x square is always greater than or equal to 0. If you look at this, x plus a square, we call complete square. This expression always greater than or equal to 0. When x equal to negative a, you're going to get 0 here on the left hand side. So we can say this expression always greater than or equal to 0. If you look at this expression, x plus a is square plus any positive number. This kind of expression always positive. It's always positive, right? Because this one can be equal to 0, but as we have positive number at the end, this whole expression always going to give you positive value, right? So our aim is to prove this quantity b square minus 4ac greater than to 0. Therefore, now we can decide what we have to do here. We need to simplify this expression to get this kind of expression. So this is actually we call complete in square form of a quadratic expression, right? So we have a quadratic expression of k. I'm going to do the complete in square for this expression. Right, so it is not a problem. We know how to do the complete in square. If you take these two terms, you can write bracket square like this, right? So we're going to write linear expression of k. We can write k as we have minus sign here. We put minus. We take half of this number. It's 1. And same time, remember, we need to subtract the square of this number, which is minus 1. At the end, we have plus 9. Now, if you simplify this, you would get k minus 1 square plus 8. You can see that this expression always positive. We seen that here, right? When you come to this stage, we can say that b square minus 4ac greater than to 0. Therefore, we can give the conclusion here. I'm going to write, therefore, f of x has two distinct roots for all values of k.